Hey guys, so I'm going to answer all the questions in this PDF, starting from number 1. When using the rectangular Cartesian coordinate system, can the magnitude of a vector ever equal to or be less than one of its components? So we're going to start off with A. I'm sure you guys are already familiar with this, but a reminder won't do any harm. So in the rectangular coordinate system, a vector is written in the form A is equals to xi plus yj, where x is the x component of the vector and y is the y component of the vector. And sometimes you might see it written like this too: ax plus ay, where ax is the x component of the vector and ay is the y component of the vector, and the magnitude of this vector is equals to the square root of ax squared plus ay squared, right? So the question is, can this magnitude of the vector A be equal to one of its components? Yes, the magnitude of the vector can be equal to one of its components, and this happens when the vector is along the axis. Yes, it's possible. I'm answering for A. Yes, it's possible. And when is it possible? It's possible when the vector lies along the axis. So as I've drawn in this diagram, in this coordinate, in this plane, in this Cartesian plane, we've got this vector A is equals to 6j, and I have also B is equals to minus 2i. B is equals to minus 2i. These vectors are along the axis. Another vector that is along the x, the y-axis is this one. Let me call it C is equals to minus 8j. And another vector along the axis is this one. D is equals to 12i, right? So I is the x component, j is the y component. In this, a is equals to 6j, there's no I component. I didn't write the I component because it's actually equal to 0. So let's concentrate on A only. When we look at A, what is the magnitude of the vector A? The magnitude of A is equals to the square root of its components, which is the square root of 6 squared plus 0 squared, which gives me 6. So yes, it's true. The magnitude of a vector can be equal to one of its components, and this is true when the vector lies on the axis. So we're done with the A part. Can the magnitude of a vector ever equal? Yes, it can equal one of its components. And then, can the magnitude of a vector ever be less than one of its components? Okay, let me illustrate this by drawing. So let's say these are my x's. This is my x. This is my y. And we've got a random vector. Right, this is my vector. Let's call it A. The x component of my vector is this. Let me do it in red so that you can see. The x component of my vector is this. What we have here is ax, and the y component of my vector is going up like this. It's ay. Great. And the question is saying, can magnitude of the vector be less than one of its components? As you can see, it can't happen. This arrow here indicates the magnitude of A, magnitude of the vector. And this line here is the x component of the vector. This is the y component of the vector. So if I draw this on the side, you can see that this is the magnitude of my vector A. And then if I take this ay and draw it this side, this is my ay, and this is my ax. As you can see, oops, is my ax. My drawing pad isn't that good. This is my x. As you can see, the magnitude of the vector is the hypotenuse of this right angle triangle. the hypotenuse is always, it's the longest side of the triangle. There is no way this side can be bigger than that hypotenuse. There's no way the AY component can be bigger than the hypotenuse. The magnitude of a vector is the hypotenuse of the triangle that we form when we draw it with these components like this. So the answer is no. No, the magnitude of a vector can never be less than one of its components. Why? Because the magnitude of a vector, when we draw it, when we visualize it, it is the hypotenuse of the right angle triangle formed by its components, and the hypotenuse is the longest side of the triangle, meaning the magnitude of the vector will always be larger than one of its components. It can never be less than one of its components. Even if it's a vector like these ones along the axis, there's no way that the magnitude of this A is equals to 6j plus 0i, plus also say 0i plus 6j, that's the normal convention. There's no way that magnitude can be bigger. There's no way that that magnitude can be bigger than that component, can be less than that component 6 or 0. The magnitude is 6. 6 is equal to 6, and it's bigger than 0. There is no way that the magnitude of a vector can be less than one of its components. I hope you understood the whole right angle triangle thing I was trying to explain there. Okay, I hope you found this video helpful. You can find number 2 of this PDF in my next video.